starting a little bit early because I have a lot of content and I know you all want to get to lunch on time. So, raise your hand if you've seen this page. Raise your hand if you've seen this page this week. Raise your hand if you've seen this page on someone else's site. So, Rails error page. I'm sure we've all seen it, the wonderful scaffold page. I know when I'm on someone else's site and I see it, I'm like, ha ha, you didn't replace the 500 scaffold with your own. Ha ha, got you. A little bit about me. I'm Aja Hammerly. I tweet at ThagAmizerRB. My GitHub is Thagamizer. I blog very occasionally at thagamizer.com, and I work for Substantial in Seattle. If you're ever in Seattle, you should totally check out our events calendar because we host lots of really cool events for developers, meetup groups, hack nights, all sorts of awesome stuff. A little bit about me as well. I have held every job I can think of in software at various times that does not have a C in the title. I have been a program manager, I've been a developer, I have been a QA person, I have been an SDET, I have been a release manager. I've worked on all sorts of projects, on all sorts of platforms, in all sorts of environments, big teams, small teams, everything in between. And if there is a mistake that can be made, I have probably been part of it. So we're going to talk today a little bit about what I learned during that and what I can tell you so that you don't have to make those same mistakes I did, because really I don't want to wish them on anyone. This talk is going to be beginner friendly. It is language agnostic because there's no code, and that makes me very sad. But if you want to see code later, come find me. I've got plenty I can show you. I'm going to launch right in to talking about debugging. Debugging is a very boring topic, but I like to do my debugging with science. So, who remembers the scientific method from middle school or high school? You know, have a hypothesis, test your hypothesis, repeat until you're pretty convinced that you have a theory, like that. You can apply those same principles to debugging, and it makes your debugging much more methodical, and it makes you much more effective. And you spend less time going, I don't know why it's not working. This should be working. So here's a basic flow chart, and we're going to go through this step by step. Most important thing, and I think this is the thing that most folks mess up right off the bat, you need to start from a known state. It doesn't need to be a known good state. I know that some days you're not going to be able to get there, but you need to have a known state, and you need to be able to get back to it at any time. This is what source control is for. Make a branch, commit to that branch, and then start debugging. Start from a specific commit, a specific revision. Or if you happen to be in GitLand, use git stash to your advantage so that you can always get back to the same place. Once you've gotten yourself a known state, whether it's good or not, you need to identify your problem. If you've got a failing test, this is done. If you don't have a test, you need to write one. Really. You need to make sure that you can always repeat the problem the exact same way, and we as humans are really, really bad about doing the same thing over and over and over again exactly the same way. And if for some reason you don't think you can test this, first of all, come find me later and we can argue about that. But second of all, write down your steps exactly. And I really do mean write them down. Grab a scratch buffer, grab a post-it note, write every step you're going to follow down exactly as you're going to do it so that you know you're going to be testing the same thing every time. When you're identifying your problem, you also need to focus small. A failing integration test is almost always too big to debug. At a previous company, I had a general rule of thumb that if there was a failing integration test, someone was missing a unit test or a functional level test between there. The only time you should have a failing integration test without something else failing is if the problem really is at the seams between two components. So try to focus smaller. Think about the layers of your system. Think about where the data starts and how it goes down and then comes back out. And focus each time on a layer. Identify your problem at a specific layer. Is the data getting munged improperly somewhere in your code? So once you have your problem statement and you've gotten it nice and simple and focused, you need to make a hypothesis. And this needs to be an educated guess. You need to use your data. You need to look at your stack traces, look at your assertion, look at the expected and the actual, and see if you can figure out why something is different there. Look at the previous steps that you've taken to debug this and figure out if one of them can help you make a good educated guess. As Science Cat says, there are two types of people in this world. Those who can extrapolate from incomplete data. And once you have your hypothesis, you need to talk to your partner. Tell your pair what your hypothesis is. Write it down in your scratch buffer. Make sure that you stay focused on your existing hypothesis. Also, avoid conjunctions. Your hypothesis should be simple. Simple hypotheses do not include the word and. Occam's razor says that the simplest solution is most likely correct, so make sure you try out all the simple hypotheses, not the user needs to be from Cleveland and it needs to be a prime Thursday before you go into the complicated stuff. So, we've got a problem, we have a hypothesis. Now we need to test the hypothesis. And to do this, we're going to do the simplest thing we possibly can to test our hypothesis. That means we're going to do one thing at a time. This shouldn't take longer than 5 minutes. If it takes longer than 5 minutes, you don't know your tools well, or your hypothesis isn't simple enough. No, really, one thing at a time. Don't refactor and debug at the same time. I see people doing this all the time, and you always seem to end up in a crazy mess, and you're not sure what code is part of the refactor and what code is part of your possible solution. There's a reason that it goes red, green, refactor. You're still in red, you don't get to refactor yet. And if for some reason you absolutely must refactor, do your refactor and then start your debugging process over from the top. I'm really serious about this, one thing at a time. If you have more ideas while you're in the process of this, write them down and come back later. This is not the idea to, oh, maybe if I do this and this. Again, there's our conjunctions. No conjunctions, simple things. So now we actually get to see if we fixed it. Is it fixed? This is where continuous testing is really handy. I love autotest. I use Guard at work too. They both work just fine. You want your tests running all the time so that you know immediately if you were successful. See if you pass stuff. So let's say you actually managed to fix your bug. Now you get to refactor. You get to clean up any print statements or comments you left yourself in the code. But don't lose the fix. This is another thing I see people doing. They get it all working and they're like, okay, I need to clean this all up. And they start deleting stuff and moving stuff around and it breaks again. So don't be afraid of showing off some not so nice code. Commit what you have and then do the refactor and then commit that. Do them as 2 separate steps so you don't get lost halfway through. And then you get to go to the next failure. And this is where autotest really shines, because once you get your first failure you're focusing on passing, it reruns all your tests automatically, so you get to pick your next failure out of the list. With Guard, you have to hit the button and tell it to rerun everything, if you haven't changed a file. But pick your next failure and go back to the top. You get to start all over again. It's fun. But what if you didn't actually manage to make it work? What if you didn't fix your failing test? Well, now you have to revert your changes. And I don't know that many people who do this. Sometimes you hit the undo frantically, but use your source control. Go back to your known state. You need to get back to a known state because otherwise you've got a mix of half a fix of one and half a fix from a different idea, and it's going to be impossible to clean up. And then you get to try again. And if you look carefully, you'll note that my arrow goes all the way back to the top, to the known state. And then you have to identify a problem again. And that's on purpose. Frequently what you learn by testing your hypothesis is that you didn't understand the problem particularly well. And you can use the information you just gained to refine your problem statement further. Maybe you realize it's not in the top layer of your system and you need to go down into the middle layers where your problem is. Maybe you can write a new test that better encapsulates where the actual issue is. Do that. Refine your problem. Get a better idea of the problem you're trying to solve, because the narrower you get, the closer you are to a solution. So that's all nice, but it's kind of high level. So let's talk about some tools and methods that can help you. Software. Git bisect. This is awesome. It is very good for figuring out when a particular thing broke. And sometimes figuring out when it broke can help you figure out why it broke. I'm not going to go into a ton of detail because there are much better tutorials online, but here's some basics. You need to tell Git that you're going to start bisecting. Git bisect start. You then need to give it a bad revision. I have never been in a situation where I want anything other than head. So git bisect bad head, or just git bisect bad tells it the current revision is bad. And then you need to give it a good revision. Some point in the past when you were pretty sure that everything was working correctly. If you're working on a branch type structure where you branch for every new feature, give it the revision that you branched off of head from, or branched off of trunk from. It's a great idea. Bisect then prints out the approximate height of a binary tree, and it uses the old binary search algorithm that we all learned playing Guess My Number growing up, where you take the whole range, you grab the one in the middle, you figure out if it's higher or lower, and then you go left and right until you narrow down exactly when an error was introduced. Cool thing about Git Bisect is that you can have it do all of that automatically for you if you give it a piece of code to run to test whether or not the bug was present. Use your test to help you here. Git Bisect run. You can also use people to help you with your debugging. Well, this actually isn't a people, it's a rubber duck, but kind of the same idea, and people sometimes are fantastic rubber ducks. Who here is familiar with rubber ducking? Raise your hand. Okay, lots of hands, so I won't go over this in too much detail. Rubber ducking is when you explain your project, your problem, to something inanimate or that roughly resembles something inanimate for these purposes. The classic example is a rubber duck. I have a 4-inch tall stuffed moose that lives on my desk, and I have explained many, many problems to him over the period that I have been coding. My last job, we had a big stuffed Grinch that I would take off into a conference room and tell the Grinch all about my problems. And the idea is that by saying what you're dealing with out loud and trying to organize your thoughts, you can often figure out what's going on, or at least you can get a good idea of what to try next. If you would feel stupid talking to a rubber duck, you can use your spouse or someone else and say, "Hi, I need you to rubber duck for me. Your job is to stand there and smile and nod occasionally. Do not talk." People are surprisingly willing to do this for you. I've also heard this called Labradoring, like you're talking to your dog. So it's a great idea. You can also ask for help. A lot of people seem really hesitant to do this, and it's a fantastic way to actually get your problem solved really quickly. Talk to your coworkers. Talk to your user group members. I'm a member of Seattle RB, and I've come to them on numerous occasions and said, "I don't know why it's not working. Can you please help me?" And they have. Hit up IRC. There are lots of people in the Ruby community who want to help you. Reach out to them, be polite to them, and see if they can give you a hand. The internet. It seems to be everyone's favorite debugging tool now. It has lots of different things there. Documentation. For your gems. For your framework. For your tools. I spent 4.5 hours debugging something 2 weeks ago. I left the work for the day, and my coworker looked at the gem documentation and found out we were not debugging a bug, we were debugging a feature of our gem. If we had started there 4.5 hours earlier, we would have wasted a lot less time. So don't be afraid to read the documentation. Every gem I've used has some. Some are better than others, but there is some. Go and find it. It's really easy to find and read it. Look at the issues and bugs. I hate to be the one who breaks this to you, but very few of you are unique and special snowflakes with unique and special problems. Every company I've worked at, pretty much, or a lot of them, have thought that they had unique and special problems, and for the most part, they really don't. Someone has most likely had the same problem you've had, and they've probably posted a bug online, and they may have even posted a solution. So look at GitHub issues. Look at bugs. If you're using something that doesn't use GitHub, lots of projects have Jira or Redmine repos that you can look at, or bug trackers that you can look at and look for someone else who solved your problem. Maybe you just need to update a gem and all of your problems will be solved. That would be fantastic. Check out the mailing lists. I'm using Devise on one of my current projects, and I have gotten so much help from the Devise mailing list. And I've never actually sent an email. I've just read everyone else's emails because someone else has had my problem, and the solution has been posted. So check out the mailing list. I've used the mailing list for other gems like Grape. It's fantastic, especially if they're on Google Groups. They're very searchable. And finally, Stack Overflow. It's pervasive. If you search anything nerdly related on Google, you're probably going to get Stack Overflow in the top 10 results. My experience is that the answers aren't actually that good. They're good enough, but they're not great a lot of the time. But it does provide a starting place. Maybe somebody in the answer uses that magic word you need to find the bug in a bug repo, or maybe they use that magic phrase, or they link to someone else's blog post that will help you solve the problem. So I consult it, but I don't ever use the solutions exactly as written. Also, a lot of people seem to read the problem and copy the code in the problem and forget to scroll down and find the solution with the green check mark next to it. So make sure you do that if you're going to use Stack Overflow. And finally, there's some cognitive things you can do that will help your debugging. Set a time limit. Ryan Davis, a couple of months ago at Seattle RB, highly recommended 30 minutes for beginners, and I think that's about right. If you're spending any more time than that, you're probably wasting your time, and you may be rabbit-holing and getting more and more frustrated when you don't need to be. And it's going to limit your ability to be effective. I think for everyone else, an hour or two is about as much as you should spend on any one problem without taking a break, asking for help, doing something else. It's a great idea to take breaks. You're going to get really frustrated, and if you start getting really narrowly focused, you may not see the actual solution to your problem, and you may just start writing more bugs and get more frustrated, and it's not a good situation to be in. At work, I go pet our office dogs. I'm like, hey guys, I need to take a 5-minute dog break, wander around the office, pet the dogs, get a snack. Some people like to get up and stretch. My last job, the coffee run, was the I'm really frustrated and I need a break thing. Hey guys, who wants to go get coffee? We go get coffee. A lot of people recommend taking a walk. I use this a lot in college. Go find someplace pretty and look at pretty things. I know some people who like to take a shower, just get completely out of the situation. The idea is that your brain is probably going to be churning away on the problem in your subconscious. Basically, you're forking a process, but you want to focus on something else. Get out of the situation, get a chance to get some perspective. Recognize diminishing returns. I know that there is a point every day where I am going to write more bugs than code. And you need to recognize that point and take a break before you make things worse and not better. So, what if you use all of your newfound ninja debugging skills and you realize it's not your bug, it's someone else's fault? Polite thing to do is to submit a bug. And so we're going to take a brief sidetrack into how to write good bugs. This is a basic bug. What I did, what happened, what I expected, and any notes. I have been using this bug template for about a decade now. It is the bug template that I used with all the testers I was mentoring at my previous job. It is the bug template that I shove into every bug system that I have to set up so that everyone tries to use this format, because it lays stuff out very simply, and it has all the information you need. And on notes, I like to put things like browser or OS versions, depending on the context. Maybe you need your software version, like your version of Ruby, that kind of thing. I also like to use a numbered list for what I did, because if you need to have a back and forth with the person fixing the bug, you can refer to steps by number, and it's a lot more clear. So, you're all awesome people because you're here. So let's talk a little bit about how to make your bug polite. No generalizations. Good bugs do not need the words always, never, no one, or everyone. If you're writing a set of steps and then you have the results that you get, it's implied that that always happens. You don't need to put the word always in. It comes across as condescending a lot of the time. Also, you need to respect people's time. Be concise. Don't prattle on. Include only the necessary information. But don't be too curt, because in our society that comes across as rude. Finally, you need to be objective. Stick to the facts. Write what happens. Don't speculate about the maintainer's intelligence or motivations or moral character. I have seen these bugs. And a quick note, the word obviously, not objective. So if you feel the need to use that, take a deep breath and then delete it. If it was obvious, the bug wouldn't be there. And finally, a great bug. Great bugs have one or more of the following. Minimum reproduction steps. Take the extra 10 minutes and get that what I did section down to the minimum number of steps you need to prove that it was correct, to prove your bug. It really helps out because it narrows down the number of places the code could be bad, and it makes it much easier for your bug to get fixed. Check related cases. If there are many different ways to do something, see how many of them are broken. If all of them are broken, that's one piece of information. If only one of them is broken, well, you've narrowed down the bug, but you also may have found a workaround so that you can keep moving even though the code's not working exactly how you want it to. Submit a failing test. I have found that this is the most effective way to work across time zones, cultural barriers, or language barriers. It is really hard to argue with a test that is either green or red. I had a team that was in Bulgaria at my last job, and we were offset by 8 or 9 hours, depending on the current state of daylight savings time. And when we were trying to integrate our pieces, I would send a test over to them when I left work for the day. They would send me code and a copy of their test run to prove that it had passed, and then I would be able to work with what they had fixed. And it was much better than me writing out bugs because it was very concrete. They knew that if they got it to green without editing my test, I would be able to work with their code the next morning. You can also provide a patch. You don't have to, but you can. If you provide a patch, do not be offended if your patch is not accepted. You are not your code. You are a fantastic person, whether or not your code is fantastic. And just because someone doesn't accept your patch doesn't mean it wasn't a good patch. Maybe they have different coding styles, or maybe they have an idea of where they're going in a future release, and there's a better place for them to put your fix in that will make the product more usable by more people, or will fit better with where the project is going long term. Finally, recognize when what you're asking for is actually a feature request. If it is something that does not exist in the project currently, it is a feature request. And if you're asking for this, provide context. One of the most common questions I ask people I'm mentoring is, what are you trying to do? Because they are great at saying, I don't know how to make an array combined with commas and semicolons and and I'm just like, what are you trying to do? They're like, I would like to print a list in English. And I'm like, great, there is array join here. So make sure you give that context, because it could be that your feature request is very easily achieved in a completely different way than you're thinking about. So that's all nice. What do you do when the poop emoji hits the fan? So, little known fact about me. I taught first responder classes and as part of an emergency response team in college. That means I got to play around with multiple casualty incidents where we dressed people up in moulage paint and pretended like there had been a fire or an earthquake and how to handle it. I went to college in Southern California, so the whole earthquake thing was kind of not that far-fetched. And those situations were really stressful even though they were pretend, but they taught me a lot about dealing with stressful situations at work and in code. And the most important thing I learned was, don't panic. When I was teaching these classes, we reminded people to take a deep breath and stop before they acted. Because in first aid situations, if you just run into an emergency situation, you are very likely to become a victim yourself and make the situation worse. In code, you're very likely to write bad code and introduce more bugs into the system and make the situation worse. So don't panic. Take a deep breath. Relax. Once you've stopped panicking, recognize the real problem. When someone's got an irate customer screaming at them on the phone, or the money situation is just completely wrong because your payment processor had a fire in their data center. Been there, done that one. They're going to start reporting bugs really badly. They're going to say, everything's broken. I hate the word broken in bugs. It doesn't actually tell you anything. So what you need to do is you need to work with your team and find the real problem. And you need to do that by coming to consensus. This means you need to get everyone, including the non-tech folks, on the same page. I like to do a written summary of these situations, a quick 1 or 2 line email, throw something in the group chat room, because it's a lot harder to have a miscommunication in the written word, in my experience. And some of these people are going to want to pester you about what's going on. I don't understand it. Maybe someone missed the meeting. If there's something written, they can refer to that and you can keep coding. You also need to use your magic active listening skills. Win friends and influence people here. People need to feel listened to when things are going badly. So repeat back to them what they say. Actually strive to understand their problem. Do not use your biases about how the technology works to assume you understand what's going on. So, let's say you got multiple problems. Problems seem to come together a lot of the time. First aid, we use triage. That's the process determining which of any number of injured or sick people is the most important right now. And an important thing I always taught is that the person who is screaming is frequently not the most important person. Because if they're screaming, you know they're breathing. That's awesome. The person who is unconscious, lying there and not making any noise, usually more important. And you need to make sure that you actually look at all your problems in code and figure out, maybe this problem that's really obvious is not actually the most important thing I can be working on right now. And for those of you who have been in Microsoft-type cultures, triage is not stand up. It is not where everyone sits in a room and says what they're working on today. Triage is also not the group whining fest where everyone points fingers and blames each other for why the product hasn't shipped yet. Triage is the process of looking at your situation and deciding what you're going to do right now and what you're going to do next. So, we understand the problem. Now we need to stop the bleeding. You need to stabilize things so they don't get any worse. Some subset of the following may be necessary. Rollback. If your system doesn't support easy rollback, it probably should. Finding a workaround. Can you meet the customer's needs with the code in its current broken state? Probably you can. Maybe that means something's lower on your priority list. Do you have a feature switch? Can you turn part of your website off? All the big websites that I'm familiar with have this. Maybe your little website should too. And finally, my least favorite, manual hackery. So you had a bug. Some data may have gotten slightly less optimal. I don't like to use the word corrupted. Maybe you need to log onto the server and use the Rails console or the DB console to fix it. If I do this, I always have someone sitting next to me because I don't want to make a mistake on the production database. And I always write down my steps. I do this by copying and pasting them out of terminal. Because every time I've had to do this, I've had to do it again later. And if you have the steps written down, you don't have to think about it the second time. So, now you get to fix the issue. Only proceed to this step once you know what the problem is, you know what order to solve the problems in, and you've tried to stabilize the system. First step does not have anything to do with coding. It is getting the resources necessary to get this code out the door. I'm using an idea of something's broken in production, so do you need ops? Do you need QA? Do you need accounting, marketing, customer support? Make a list of what you need, give it to someone else and say, if you want this fixed, get me these people. Guaranteed they will make this happen for you. Because what you don't want to have is finish all your code, get everything great, and then realize you still have 4 hours to get the QA guy and the ops guy and everyone else on board so that you can get this out the door. Then you need to write a test. Do you ever want to debug the same problem again in 3 months? I don't. I'd like the CI to catch it so I don't have to do this again in 3 to 12 months. Then use your magic scientific debugging skills that we discussed earlier. Don't be sloppy. And then, this is kind of contentious, but I think that any more than 2 streams of work on a given problem increases the technical overhead to the point where you're not going to be as efficient anymore. I like to pair, especially when I want to be careful about something that needs to be right the first time, so no more than 2 pairs. If you have extra people, tell them to go do workaround. Make one of them your communications person, and they deal with all the communication in and out of the team. You update them, they write your emails for you. And then set expectations. Everyone wants to give an estimate. Someone's like, when is it going to be fixed? When is it going to be fixed? I really hate giving estimates, especially when situations are tense. What I do is I say, I'll give you an update in an hour. I'll give you an update in 2 hours. I'll give you an update before I go to lunch. If you have to give an estimate, multiply by 2. Everything takes longer when you're not doing it as part of your normal process. You have to go find the QA guy. Maybe the ops guy has to go pick up his kid from soccer, and only then can he push the code to production. Uh-oh. Improving estimates. Quick sidebar. Almost every engineer I know is bad at estimates. You can get better at estimates. Before you do something, write down how long you think it's going to take you. After you do it, write down how long it actually took you. You can use a Pomodoro timer or the stopwatch on your phone. Then spend 5 minutes thinking about why those 2 were different. If you do this enough, and really a week or 2 is often enough, we'll get a lot better at estimates very quickly. Also, you need to communicate. You need to communicate often. When something's wrong, you need to communicate in writing. People can refer back to this and get their warm fuzzies that they know that you're trying to solve the problem. This way they don't pester you and you can focus. You also need to communicate in public. We like to hide our mistakes. It's talked about this morning that there's no shame in mistakes. That's how we learn. You need to share updates with more people than you think you should. You need to share updates with the non-technical people. Don't hide information in a crisis unless there is a real privacy concern. Also, if you have a lot of technical people and non-technical people on the same email thread, 2 or 3 sentences of non-technical summary followed by as many technical details as you want. I promise the non-technical people will stop reading when it gets confusing. Finally, you need to communicate predictably. Set a schedule and stick to it. If your email needs to come out by 4, it better come out by 4. And re-triage. Re-triage during your day to figure out if the priorities are still the same. Finally, you need to reflect. Once things are fixed, take the time to reflect. Reflect solo once your heart rate is back to normal. I like to go get cookies and then think about the problem. Reflect with your team. I like the 5 whys format. Basically what this is you state the problem and then someone plays the petulant 5-year-old and asks, why? And if you do this long enough, you will get to the underlying problem, not the problem that was appearing on the surface, and you'll fix the problem, not the symptom. Finally, keep it fact-based. Don't blame. State things that actually happened, don't state your interpretation of what happened. And keep it future-focused. Focus on how you can get better next time. I don't like to add process. Process usually indicates you have a communication problem. I favor education and pairings to get everyone on the same page and make sure everyone understands the whole system. Finally, summary. Debug with science. Don't panic. Communicate. Respectfully and responsibly. You need to communicate if you want to get through difficult situations. A special thanks to Ryan Davis and Pete Higgins for reviewing my slides and helping me rein in this rant. And for Ben and Karin for running this conference. It's a great conference and I'm really glad they keep working on it. Thank you. And this is a fantastic cartoon about first aid from college. I will be around later. I will be the one in pink. Ask me questions.